Bismillahirrahmanirrahim. Assalamu alaikum. Hello and welcome to Dr. Saqib Khan Science Academy. In today's tutorial, we will discuss about how to calculate band gap using Tauc plot. The formula for Tauc plot. Using this formula, alpha h mu power 1 over n is equal to a h nu minus eg. Using this formula, using this equation, we will calculate the band gap energy. In this equation, alpha is the absorption coefficient, h is the Planck constant, nu is the photon frequency, alpha is the proportionality constant, and Eg is the band gap energy. Okay, Eg is your band gap energy, while n is the exponent that depends on the type of electronic transition. We have two types of electronic transition, direct or indirect transition. Okay, if the value of n is equal to 2, this means that it is the direct allowed transition for the direct band gap. Okay, we calculate the direct and indirect band gap. So if the value of n is 2 and if the value of n is half or 1 by 2 indicates indirect allowed transition for indirect band gap. So how will you know that whether it is direct band gap or whether your band gap is indirect? So from the graph which we will draw the graph which is more fitted graph, from that graph you will come to know that whether it is direct band gap or whether it is indirect band gap. You will calculate the band gap using the value of n is equal to 2 and using the value of 1 over half. Both the graphs you will calculate and then you will compare those graphs, and then from those graphs you will select whether your material is showing direct band gap energy or indirect band gap energy. Okay, so we know that E is equal to h nu. Okay, nu is the frequency, so we already know frequency is equal to c over lambda, velocity over lambda, or c over here is the light velocity. So by putting the values, as these values are constant values, h and c values are constant values, so we can use these values to calculate the energy if we already know the lambda. The h value is in joule, so we will convert it into electron volt as we need the energy in the electron volt. So we already know 1 electron volt, the value of 1 electron volt in joules. So by putting these values, we will get this kind of equation. By simplifying this equation, we will get 1.240 into 10 raised power minus 6 electron volt meter divided by lambda in meter. So we will get, if we convert this, we will get this kind of values. Now the lambda which we obtained from the UV visible spectrophotometer is in nanometer. So we will convert this meter into the nanometer. So by converting it into nanometers, okay, we already know that 1 nanometer is 10 raised power minus 9 nanometer. So we will get this kind of results, 1240 electron volt nanometer divided by lambda in nanometer. So nanometer, on both sides the nanometers will cut each other, so we will get this kind of, the final equation which we will get is E is equal to 1240 divided by lambda electron volt. So by using this equation and the absorption coefficient and the value of alpha, we can calculate the band gap energy using Tauc plot. For the absorption coefficient, I already made some videos on the absorption coefficient, so you can check my channel. I will give the link in the description, so you can calculate the value of absorption coefficient from there. I will not go into the detail in this video because it will be very long video if we calculate the absorption coefficient and everything. So we will just focus on the calculation of band gap energy. For the absorption coefficient, you can check my other videos as well. Now let's go to our data which we obtained from the UV visible spectrophotometer, and then from there we'll proceed with the band gap calculation. So after coming to the origin, after opening the file, we have wavelength and absorbance of our material. Now we will calculate the absorbance coefficient and the energy of this material based on this data, and then from there we will calculate the direct band gap and indirect band gap. If n is equal to 2, then that will be our direct band gap, and if n is equal to n, and when we take the n as 1 by 2, then that will be our indirect band gap. So for calculating the absorption coefficient, we denoted it as alpha in our, when I was explaining this, so I will take alpha. So I will write the formula over here, but if you want to have some more information how it is calculated and what is the story behind this, then you can go to my channel, and over there I have explained that how to calculate the absorption coefficient or alpha, the value of alpha, and how where you can use these values. So the formula over here which will be used is 2.302 multiplied by the value of absorbance. As the absorbance is column 2, then so we will select as the column 2 over here. Okay, now as we calculated the absorption coefficient, now we will calculate the value of energy. Energy, we already know that energy is equal to h nu or hc over lambda. We calculated it. Then the formula which we got was 1240 divided by lambda in electron volt. So energy, it is in electron volt. Sorry, it is in electron volt, and the formula which we used was 1240 over lambda. The value of lambda is in column A, so we will write it column A over here. Okay. Now as we have absorption coefficient and as we have energy, we can see over here that h nu is our energy. Okay, h nu is our energy and alpha is our absorption coefficient. Now we will get the n value. We have the n value, that is for the direct band gap it is 2, and for the indirect band gap the value of n is 1 by 2. So when n is equal to 2 and half, so okay, so over here we'll put our formula. It is alpha h, and let's have a new symbol, alpha h nu power 2. If power 2, then this is our direct band gap. This is our direct band gap, and if it is half, 1 by 2. If it is 1 by 2, then this is the indirect band gap. Okay, so for the direct band gap, we have alpha. Alpha is in column C. Alpha is in column C multiplied by energy value or h nu value, that is in our column D, and power 2r square of this. So we will get the direct band gap over here. For the indirect band gap, the formula is alpha, the value of alpha in column C multiplied by the value of energy or h nu is in column D, power 1 by 2 or 0.5. Both are same. So this is our indirect band gap. Now we will take our initial graph of the absorbance. This is our graph for the absorbance. You can increase its width, the line width. So this is our the value of our absorbance, the graph of our absorbance. Then we will go to our book again and calculate the and make the graph for the direct and indirect band gap, and the one which gives best fit with the y-axis, with the x-axis, that will be our best fit. So first of all, set this energy as x-axis. Okay, then make a diagram over here. So this is our direct band gap. Now we will go for the indirect band gap, and we will compare both the graph. For selecting, just put control, just put press control and select that column, and go for the indirect band gap. So now we have both direct and indirect band gaps. Now you have both direct and indirect band gap. So for here, for me, this direct band gap, it can give me best fit. Let me draw it over here. So if I draw this thing for the direct band gap, this is my direct band gap. Let this thing as red color, and when we do the screen reader over here, this is the direct band gap is 3.04. So let's write it over here. Our direct band gap is EG is equal to 3.04 for this material, and indirect band gap, if we go to our indirect band gap, this one, for the indirect band gap, we'll consider this one, and change its color. So this is our indirect band gap. We'll take the screen reader 2.82. So indirect band gap EG is equal to 2.82 electron volt. So I think this one gives us best fitting over here. So we'll consider this for this material as the indirect band gap. You can copy this. Okay. You can copy this and paste it in your main graph. Whenever you are reporting it into your paper, you will have to put this one like this. You can increase like 28, make it bold. This one has 32. This one also has 32. You can play with these. Hopefully now you understand how to measure and how to estimate the direct and indirect band gap from the UV visible spectrum or UV visible absorption data, and how to report it in your thesis or in your paper. If you got some information from this video or from this tutorial, please like, share and subscribe to my channel. Thank you very much, and Allah Hafiz.